Alright, you're welcome to this class. I still remain your tutor, Mr. Pascal. Today we are looking at index notation and function, the almighty awaited topic we want to treat. Though it's a very short topic anyway. Okay, so what is index notation? Index notation is a way of shortening a product of equal number. You know, just like, for instance, if you have A times A times A times A, okay? Now, this can be said to give you A raised to power 5, for instance. Just like we can have like 3 times 3 times 3, or 4 times 4 times 4. You know, this can give you 3 raised to power 3, and this one can still give you 4 raised to power 3. Okay, so if you look at this, this is what we mean by index notation, shortening the product of a number, okay, of equal value. Okay, now if you have A raised to power 5, for instance, this is considered to be the base. Now, the 5 here is called index, or simply you can call it power. Okay, so the same applies to this. If you consider that of 3 here is the base. The 3 that is much bigger than the other is the base. Now, this little one here is called the index, or you call it the power. The same goes to this 4 and the 3 there. Now, when you talk about law of indices, you know, there are laws you need to apply to solve some things on indices. We call it law of indices. Law of indices, in that we have about 8 of them. We have multiplication law, we have division law, we have power law, we have product power law, we have root power, we have fraction index, we have zero index, we have negative index, we even have decimal power base. Okay, and after we are done with some illustration of this, we finally bring you exponential function. That is the function we have here, exponential function. Okay, so with that we call index notation and function a day. All right, so stay tuned while I bring a breakdown on that so that we can ride along. Okay, all right. Okay, welcome back. So we start with law of indices. Laws of indices. Okay, indices is the plural of what? Index. Okay, starting with the product law. Product law states that when a number of equal value or equal base are being multiplied, you simply add their what? Their index or their power. For instance, if you have A times A times A times A, this is just saying, because looking at this has 1 each as their what? As their index. So what you do is say 1 plus 1 plus 1 plus 1, and this will give you a total of A raised to power what? A raised to power 4. Okay, and if you have 2 times 2 times 3 times 3, this simply means that we have 2 here, 2 into 2 different places, and we have 3 into 2 different places. What you simply do, you say 1 plus 1, because the 2 we just have 2 of them here. Okay, and in each of the 2 we have 1 as the as the power. So adding the 2 together, we have 2. Okay, so this will give us 2 raised to power 2, and the other one is 3 raised to power what? 1 plus 1, and this will still give you 3 raised to power 2. Okay, it simply means that a raised to power x times a raised to power y will give you what? Will give you a raised to power x plus y. This is what it simply will give you, because we are dealing with what? Product law. Okay, now when you are dealing with the products, or rather the division law, the division law, the division law states that when when numbers of the same base are being divided, okay, what you simply do, you minus the power of the divisor from the dividend. Okay, now if you have, for instance, b times b times b over b times b, now this will simply give you that b is raised to power 3 here, and the downward, the divisor is b raised to power 2. So division law states that you can simply say b 3 minus 2. Okay, 3 minus 2. With this now we have what? We have b equal to what? 1 raised to power 1. And you remember in mathematics, you don't normally write that 1. So what it simply means that this is equal to what? B. Do you understand? All right. Now, if you have ax divided by ay, that will simply give you a raised to power x minus y. Okay, that's in general. Now let's talk about the power law. Okay, let's talk about the power law. Okay, now the power law, the third law. Okay, this law states that when a number is raised to a power, and that power is also raised to another power, they are said to be in powers. Now, what you do is, if you have, for instance, 2 raised to power, maybe 3, and they are also again raised to power another 2, so they are said to be in powers. What this simply means, if you are to express it out, now you can have that 2 raised to power 3 times 2 raised to power 3. Okay, this is what it simply means. And if you say 2 raised to power 3 times 2 raised to power 3, it will give you 2 times 2 times 2 times 2 times 2 times 2. So we have this from here to here for the first one, and from here to here for the second one. And if you multiply out, just like our product rule will tell us, that this will simply give you equal to 2 raised to power. How many are they? 1, 2, 3, 4, 5, 6. 2 raised to power 6. 1 plus 1 plus 1 to 6 times, you have 6. Now, if you also represent it as thus, for power law, you can say that 2 raised to power 3, okay, because they are in powers. You can now say this times this, okay, 3 times 2, and this will equal simply give you 2 raised to power 6. If you look at it, they are the same. Okay, so when you have it like this, you multiply the 2 powers. That will give you the general form, or the final form of what you have in the brackets. Now, quickly, we are going to look at product power law. Okay? Product power law. All right, so for the fourth one, we have product power rule, law. Now, dealing with this, we simply mean that if different numbers of, numbers that have different values, okay, are multiplying each other, perhaps in the brackets, and they are raised to a certain power, what you do is you distribute that power to each number contained in that bracket. So if you, for instance, say 2xy raised to power 3, okay, what you simply means that 2 raised to power 3 times x raised to power 3 times y raised to power 3, okay, and this will just simply give you 8x cubed raised to power 3 y raised to power 3, okay. Now, in general, if you have x y raised to power 2, what it simply gives you is x raised to power 2 times y raised to power 2, okay. So that is what it means. So you simply drop it to x raised to power 2 y raised to power 2, okay. All right, now we are going to look at root power law. Root power law, okay. Follow me. Okay, now we look at the fifth one. The fifth one says root power law. Now, in this, if we consider, for instance, maybe 2 raised to power 1/2, for instance, okay, what a root power states that this can be thus square root of 2, okay, that is square root of what? 2, because this alone, with this alone, you can even remove this can still mean square root of 2, okay. Do you understand? Now, if you have for maybe 2 raised to power 3, 1/3 rather, okay, what this means is what? Cube root of 2. And if you also have it maybe for 4th root, and so many of them, you simply have what? 4√2, okay. I'm not saying it must be a 2, okay. For instance, if you have maybe 16 1/2, this can give you what? Equal to root 16, and this is simply what? This is simply 4, okay. Now, whereby you have as a power law we denote, if you have probably 2 raised to power 1/2 times 2 raised to power 1/2. Remember our first law, the product law. Any number of the same value or the same quantity with what? With index, you simply what? You simply add their index. Okay, with this we can have that 2 raised to power 1/2 plus 1/2. And if you look at this, if you take the LCM of the index or the power, you can simply arrive at what? 1. And any number raised to power 1, we are coming to that. Any number raised to power 1 is still what? Itself. So we have 2. Okay. Now, for instance, also if you have 16 raised to power 1/3, okay, this is simply telling you that you have 3 cube root of what? 16, And cube root of 16 is what? Cube root of 16 maybe cannot be determined. For instance, if you have like 8, okay? If you have like 8, cube root of 8, for instance, this will give you 2, okay? Because 2 times 2 times another 2 will give you what? Will give you 8. So this is actually what we mean by what? Root power. Now, if, for instance, you have maybe a raised to power 1 over 4 times a raised to power 1 over 4 times a raised to power 1 over 4 times another a raised to power 1 over 4. This generally will give you what? A raised to power what? A raised to power 1. Because the 1 over 4 is distributed into 4 different places. Okay? You have a raised to power 1, and this will finally give you what? A, because anything raised to power 1 is still itself. Now, if you have a, if you have a, okay, a maybe raised to power 1 over n. This n can be any number. Okay, this n can be any number. What is simply we give you in general is that n cube, the nth term or nth term, what? Root nth term in bracket, and in that root you have what? You have a. Root nth term, you have a. Okay. Now, this a may be probably 2, 3, 4 numbers. Okay, and this n as well can be any number. Okay, that when you consider this number, you check what will be multiplied into that number. If it's 4, a number that when you multiply it into 4 different places, it will give you what? A. That will come out as what? As the number. If it's 3, you consider a number when you multiply it into 3 different places, it will give you A. That will be the number. Okay, so with this, I believe you understand what we mean by root power law. Okay, so quickly we are going to look into fraction index. Okay, fraction index. All right, now the 6th one, we have fraction index law. Okay, in this law states that or rather considers that at times the power can be more than maybe half, or 1 over 3, or 1 over 4, or 1 over 5, as the case may be. It might be, for instance, a raised to power maybe 2 over 3. Okay, now this has gone off from what? 1 over 3. We know from the other law. Okay, in this case, the fraction index states that you take the what? The nth root, or you take the cube root, because 3 is the denominator here. You take the cube root of this a, and what? Later, you raise it to power of 2. So in simple term, we can say that a raised to power x over y. We can simply say that you first of all take the what? The y root of what? Of this a. And after you have gotten the y root of this a, you raise it to power x. Or you can say maybe a raised to power m over n. You take the nth root of a, okay, and raise it to power what? M. Okay, now with this you can just say that nth root of what? A raised to power, or raised to power what? M. Okay, whatever you get as the nth root of a. Okay, raise that number to the power of m. So that is what the fraction index law denotes. Now, if you have, for instance, maybe 16 over, or let's say 8, for instance, over 2 over 3, for instance, what this will give you is what? You simply say cube root of 8 raised to power 2. So when you take the cube root of 8, now you are going to arrive at what? 2. Now that 2 raised to power this 2 will give you equal to 4. So that is what we mean by what? Fraction index law. Okay, now we are going to look at zero index as one of the laws of indices. Okay, so zero index law. Now, when you consider zero index law states that when any number is raised to power 0, that number becomes 1. Okay, for instance, if you have if you remember our division law that states that if 2 raised to power maybe 3 divided by 2 raised to power 3 again, if you watch this, they are the same entity. I mean, the same value here is the same value here. So whenever you have such, the division rule says that we can take the words, we can take the difference of the word, the power, and with this we have 3 minus 3, and this will give you 2 raised to power 3 minus 3 is 0. Okay, so once you have it like this, what it means that all of this quantity is equal to 1. That is zero index law. And even if you have 1 million, 1 million, for instance, okay, 10 million or 1 million, anyhow, that is what? Raised to power 0. Simply will give you what? 1. So any quantity raised to power 0 is 1. So what that means, therefore, is that if you have a raised to power 0, okay, this a can be any number, is equal to 1. If you have n raised to power 0, that n can be any number, is equal to what? 0. Is equal to 1, rather, sorry. Okay, so any number you raise equal to the power of 0 will give you 1. That's zero index law. Now we are going to take the negative index law. Okay, when you talk about the negative index law, you are simply considering that any number or any entity or any quantity that is raised to a negative index simply means what? Taking the reciprocal of that same number raised to the positive index. Let me say it again. If you have a number raised to a negative index or power, you take the reciprocal of that base and raise it to the positive of that index. When you let's take for instance, if you have maybe 2 raised to power minus 3, okay, 2 raised to power minus 3, what this simply will be, what is having 1 over 2. Remember, this 2 is an integer, is a whole number on its own. Now for you taking the reciprocal of this number would arrive you at what? Turning this upside down, because this 2 is just like saying over what? 1. Now, when you turn this 2 over 1 upside down, you now have 1 over 2. Okay, so this index now we now change to what? A positive index added to that same number, the same base. Okay, now this is what it actually means. Now, if you want to do more demonstration, you can take, for instance, 2 raised to power 3, okay, minus divided by 2 raised to power 6. Okay, remember our division rule. We simply take the what? We simply minus the what? The powers. So with this we have 2, 3 minus 6, and this will end up giving you 2 raised to power minus 3. Okay, so if you also want to have more demonstration, you can express this out, okay, and know if you can arrive at this minus 3. Okay, we have remember, this is the what? The one of the numerator side. We have 2 times 2 times 2 all over 2 times 2 times 2 times 2 times 2 times 2. Okay, with this we cancel out, we cancel out, we cancel out. Now we are left with what? Equal to 1 over 2 raised to power 3 is getting us back to this place. Now from here you can still return this, because this is the same thing as this. Okay, so you can still return this as equal to 2 raised to power minus 3. So either of these are the same. So that is what negative index law states. Okay, so simply we can say in general, if you have a raised to power n divided by a raised to power m, this will simply give you what? We simply give you a raised to power n minus m. Now, if m is bigger than n, now your answer will arrive at what? Your answer will arrive at negative sign. Okay, and with this you can treat it with what? Negative index law. All right, now at this point we are done with the law of indices. We can actually chip in that of decimal power base. Okay, with that we can move down to exponential. We give some examples and some examples before we go down to exponential function. Okay, with that we call it a day. All right.